Alright, so here's my egg composition entry. So the whole idea here is trying to reduce the amount of force that goes to the egg. So the idea is that, and this is all made with stuff from my recycling bin, by the way. So what you do is we're going to drop it from the top of this bridge in a little while. We're at the Cumberland bike path right now. But first we're going to figure out how high this bridge is by actually dropping a ball, and then there's an equation we can use to figure out the height. So let me explain my design. So the idea is that this is going to drop down. This piece right here in my hand should act like a parachute, and then it'll drop on the ground. And then this is a crush cone. So the idea is that this will actually compress and crush to absorb a lot of the force instead of the egg. Right here we have, this is actually all built around the inside of a tape roll, and then the egg goes inside here. This is, it's kind of like the paper equivalent of bubble wrap. It's actually wafted. So the egg is going to go in there. We'll put a little bit of tape to close everything up, and then we're going to drop it, and we'll see what happens. Okay, so now's the part of the video where I would show you how I calculated the height of the bridge. So what we did is I had a timer going on my phone, and the person at the top of the bridge dropped a tennis ball, and when they dropped it I started the timer, and when it hit the ground I stopped the timer. And so then I plugged it into an equation. So this should look familiar. This is from our equation sheet. So to simplify this, we know that V0 is 0, so V0t cancels out. And here we are. I also changed delta y since we're working in the y-axis, not the x-axis, so vertical instead of horizontal. Let's plug in 9.8 for a and divide that by 2. We get 4.9. Now if I could plug in my time right to there and I'd get the height of the bridge. But that's in meters, and it's, for us in the United States, a little harder to visualize what a couple of meters looks like as opposed to feet. So then I converted, so 4.9 times about 3.2808, and that gives us 16. So 16t squared. For a time I got about 2.56. So we'll square that, and we get 6.5536 times 16, and that's 104.85, which is pretty close. I did some research online, and I found the reported height of the bridge to be 90 feet. So that's the height that I'm going to be using for my egg drop. Okay, they're going to drop it now. I'm curious to see what happens. Alright. Oh, it's dropping backwards. Okay, we'll see. Well, I think the parachute worked pretty well, although it dropped upside down, so we'll see what happened. Let's open it up. Oh, yep, we got a cracked egg. Oh well, it's on the ground there. Let's open it up and see how bad it was.
There's dinner.
There's dinner. No, I got it. Oh, I open it up a little more. So it landed with this brown paper face down, which is the exact opposite of how I wanted it to land. But yeah, that's pretty cracked. Oh well, I think we did some good physics today. And that was quite interesting. Very cool. So as we're walking back to the car now, I've been trying to think about what went wrong with my design. So I think one thing that went well is the parachute worked quite nicely. And that was just made out of tissue paper, and then I reinforced it on the edges with some thin chipboard or cardboard strips. Then I had 4 strings in each of the 4 corners attached to the where the egg was. But I think what went wrong is I think the whole top portion of my design, right where that egg was the heaviest. So I think that's it caused it to tip over because it was top heavy, and that's why it landed like it did.